Welcome back to the video lecture series of Digital Fundamental. Today we will discuss semiconductor memories. So let's start with the definition of memories. Here we have a memory. Memory is a device which is used to store data or informations. Okay, memory is a device which is used to store our informations, our data bits. Okay, this memory is basically constructed using a different cells or says using flip-flops. Okay, so this memory is basically in a form of cells, and these cells are used to store numeric data or alphanumeric letters. Okay, so in a memory we can store our numeric data or alphanumeric letters. Okay, so using this memory we can store any information bits, and this semiconductor memory is basically a memory which is constructed using semiconductor ICs. This semiconductor memory is basically a memory device which is constructed from semiconductor ICs. Here we have a classifications of memory. Memory can be classified as first ROM, that is read-only memory. That means a memory device in which we can only perform the read operations. Okay, so here we have this read-only memory, and in this read-only memory we have a MROM, that is mask ROM, PROM, that is programmable ROM. Then here we have a EPROM, that is erasable programmable ROM, and here we have a EEPROM, that is electrically erasable PROM. Okay, so here we have a classification of read-only memory. Then we have a next memory, that is RAM, that is random access memory, which is read and write memory. Here we have a SRAM and DRAM, that is static RAM and dynamic RAM. So here we have a basic memory, that is our ROM and RAM. ROM, that is read-only memory, and RAM, that is read and write memory. We have another classifications of memory, that is content addressable memory, and next we have a charge coupled device memory. Okay, so here we have a classification of memory. So let's discuss one by one this ROM and RAM memory. Here first we have a ROM. Okay, so ROM, that is read only memory. This memory is basically used to store our data at once, and then this data cannot be altered, cannot be modified into that devices, and here we have only read operations there. That means this stored data can be read or says can be retrieved from the memory, and all the data are permanently stored in the memory. Okay, here this ROM is basically used to store the data which are permanently stored into the memory. Okay, so here in a ROM we can store the data which are permanent in a nature. The desired binary information must be specified by the user, and it can be stored into the memory at a manufacturer side or at a designer side. So this binary information in a ROM is already designed into the memory and already specified into this memory. So this all informations can be retrieved here. No informations can be altered. Once a pattern is established, this information cannot be erased or cannot be reprogrammable. Here we have a basic block diagram architecture of this ROM. Here we have an address. So whenever we want to identify any information or whenever we want to retrieve any information from the memory, here we have to apply this address. At these locations we have a data. Okay, so here address is specified. So at that address we have our desired data. So here we have this address input, and here we have a data output. That means at these locations we have this kind of data. Okay, so this is basically read only memory. That means we have to just specify address, and at that address whatever the data is stored is retrieved at a data output side. Okay, so this is our read only memory. Now this ROM is basically designed for fixed types of data. This ROM is basically designed for a fixed type of data. That means the data which are always stored for a once, and these data are not going to be altered. Okay, so this ROM is used to store these types of information. This ROM is also used to implement various combinational logic circuit. This ROM is also used to implement various logical circuits, says various combinational logic circuits. Now let's discuss various types of ROM. So first here we have a MROM, that is mask ROM. Okay, so the mask ROM is basically a type of ROM in which data are stored into the MROM, or says in a mask ROM at a manufacturer side. Okay, so data are stored in the memory device at a manufacturing durations. That means data is permanently stored over here, okay, at a manufacturing sites, and no user can or no customer can reprogram them again. Here photographic negative, which is known as mask, is used to store the informations. Okay, this photographic negative, that is known as a mask, is used to store the informations, and for each and every binary pattern or each and every bits here a special kinds of mask is used to store the informations. Okay, this mask is basically store our information at a manufacturing side according to customers specifications, and once the data are stored in a mask ROM, it cannot be altered, it cannot be altered, or it cannot be erased. So this mask ROM are basically inexpensive when these are produced in a large quantities. Okay, if these ROMs are produced in a large quantity, then these are the cost effective. And here in this mask ROM we have a different types of data stored in the informations at a manufacturing sites according to customer specifications. So the disadvantage of this mask ROM is that it is not reprogrammable. That means it is not erasable. So if any error is occurred, that is a wastage of this memory devices. Okay, because it cannot be altered of a data, or it cannot be modified. Okay, so this is our mask ROM. Next we have a pre-ROM, that is programmable ROM. Okay, so here we have a programmable ROM. This programmable ROM, that is PROM, is not programmed during the manufacturing process, but it is programmed by the user according to customers specifications. Okay, according to customer specification it is programmed after the manufacturing process, but it is once programmed, then it is similar to the mask ROM. That means whatever the data are stored over here, it cannot be altered. Okay, so whatever the data are stored over here, it cannot be altered. So once this PROM is stored, okay, once the PROM is programmed, then no data is altered in this and no data is erased over here. So this is our PROM, which is suitable for data which are permanent in nature. So this is a PROM in which data are stored over here only once. That means data are stored over here permanently, and once the data are stored, then there is no modifications of data, and this PROM cannot be reprogrammable. Okay, next we have a EPROM, that is erasable PROM. So this erasable PROM is a PROM in which we can erase our data. Okay, this erasable PROM, that means a type of PROM in which data can be erasable. That means according to customer specifications or according to the requirements, these data are basically erasable according to the requirements, and these data can be programmed with ease and at a very small cost. Okay, so this erasable PROM is basically store the data, and if we want to erase some data, so here we can erase that data according to customer specifications, and we can again reprogram them. Okay, this memory is again reprogrammed, so depending on the requirements, this data can be erased and these data are again reprogrammable over here. Okay, so this is our erasable PROM. Once the data are programmed over here, okay, in EPROM, once the data is stored, this EPROM is basically non-volatile memory. That means whatever the data are stored over here is always stored in that, even if the power is turned on or turned off. Okay, so this EPROM is basically non-volatile memory in which our data are stored indefinitely. Here in EPROM, to erase the data, we have to apply this ultraviolet rate or says UV rays. Okay, so in EPROM, and we apply this device in a UV radiations. Okay, if we apply this memory device in a UV radiation, then all the connections and all the stored data over here are erasable, and this erasing times requires, or says this erase time of this EPROM is basically 15 to 30 minutes depending on the size of data. Okay, so this erasable PROM is basically a device in which data can be erased by using ultraviolet radiations. Okay, using ultraviolet radiations we can erase the data, but here whole the data or whole the memory is erased. There is no way to erase only selected data. Okay, here we have to erase all the stored data. That means once we apply UV radiations over this memory device, so all the data stored over here in EPROM is erased, and we can again reprogram them. Okay, we can again reprogram them, but no, there is no way to erase only selected data. Okay, once the data is erased, EPROM can be reprogrammable. Okay, once the data is erased, this EPROM is again reprogrammable totally. So here whole memory is erased. Okay, whole data are erased over here. There is no way to delete only selected data. Okay, so erase selected data. We have a next EEPROM, that is electrically erasable PROM. Okay, this electrically erasable PROM is basically advancement in this ROM technologies. Okay, this is a basically advancement in a ROM technology that our data is erased with electrical connections. So using this high power radiations we can erase the data. Okay, using high power radiation selected data are erased over here. Okay, selected data are erased over here using this electrically erasable memory. Okay, so using high power we can erase the selected data, or we can erase whole the memories. Okay, and this erasing time require less time. Okay, so unlike the UV ROM, okay, unlike this UV EPROM, here there is no need to place this ROM into the device to erase the data. Okay, so here no need to place this device or says this memory into different environment. Okay, and once the data is erased, again we can reprogram them depending on the requirements. So in a EEPROM, or says in a electrically erasable PROM, this data are erased and again reprogrammed with power requirements. Okay, depending on this power we can either erase or we can reprogram the data in this memory device. Here this memory device is basically integrate both erasing circuits and this reprogramming circuits. Okay, and using this integrated circuits for erasing and for data storings, we can erase the data and we can reprogram the data, and here only single bytes can be erased. Okay, here we can erase single byte, that means only one bit data or only selected data can be erased in this electrically erasable PROM, and here we have a very short erasing time. Okay, in a electrically erasable PROM we have a very short erase time, and here we have this EPROM is basically non-volatile memory. That means our data is stored in a memory even if power is turned off. Okay, so this is our ROM classifications. Now let's discuss about RAM. So here we have our next RAM, that is random access memory. So this memory is basically a memory which is used to store information, and in this we can store our informations and we can write informations. Okay, so this random access memory is basically read and write memory. That means we can retrieve our data or we can store our data. Okay, so this random access memory is a memory which is used to store the informations which are not in a permanent in a nature. Okay, which are not permanent permanent in a nature. So here in a random access memory, we can read the data or we can write the data. So this RAM is used for temporary data storage. Okay, so this RAM is used for data which are temporary. This RAM has basically read and write operations. This RAM has a read and write operations. That means we can retrieve the data from memory or we can store our data from a memory. If we retrieve our data from a memory, that means read operations, and if we write some data on a memory, then it is a write operations. Okay, so in a RAM we have a read and write operations. That means we can either retrieve our informations or we can store our informations. And this RAM is basically volatile memory. That means if power is turned off, then the data is lost. Okay, so this RAM is basically volatile memory. That means whenever there is a power turned off, so we have a loss of data. Okay, so this is our read write memory, or says random access memory. Here we have this kind of block diagram for this RAM. Here we have a RAM, here we have a address bus. That means it provides the address. Here we have a bidirectional data bus. Here we have a bidirectional data bus. That means we have both the directions transfer. That means we can retrieve the data from memory or we can store the data in a memory. Okay, we can store the data in a memory, and here we have a read and write control signal. That means if we want to retrieve the data from memory, so we have to apply this read operations, and here we have this read slash write bar. That means read operation is active high, write operation is active low. Okay, so whenever we want to retrieve the data from a particular location, so apply the address of that location, apply this read slash write bar is equals to 1 for read operations, and if we have this read and write is equals to 1, so at a given locations whatever the data are retrieved at this data bus. Okay, and if we want to store the data, so this read and write bar is equals to 0, because here we have a write, that means write operations is a active low. So whenever we have this 0, so we have a write operation. So here whatever the data we send, okay, here we can send data from either memory or from memory. Okay, so here whenever we apply the address and whenever we provide the data, so this data is stored into the memory at the desired locations when we have a write bar is equals to 0. Okay, so here we have a read and write operations. When read and write bar is equals to 1, we have a read operations, and whenever we have a read and write bar is equals to 0, so we have a write operations. Okay, and whenever we want to retrieve our data, so make this read and write bar is equals to 1, and whenever we want to store data in a memory, so make this read and write bar is equals to 0. Okay, and whenever we want to retrieve our data or whenever we want to store our data, so we have to apply the address for this locations, and here whenever we want to read our data, so this bidirectional data bus work as a output, and whenever we have to store our data, so it works as an input. Okay, so this is our read and write memory, or says random access memory. Here we have a SRAM, that is static RAM. So in a static RAM, data can be stored as long as power is applied. Okay, in a static RAM, data can be stored as long as power supply. Here in a SRAM, each memory cell is basically designed using flip-flops. Okay, each memory cell constructed using flip-flops such that it stores the data, or says it stores the information in form of bits. Okay, here in a SRAM, our data are stored in form of bits in a flip-flops. Okay, our data are stored in form of bits in a flip-flop, and this flip-flops will stay in a given state. Okay, this flip-flops will stay in a given state at a required durations of a time. Okay, at a required durations of a time, our data are stored in this flip-flops in form of bit. This SRAM use 6 transistors in each memory cell. Okay, this each memory cell of this SRAM is designed using 6 transistors. Here in each and every cells we have a flip-flops, and this flip-flops contains basically typically 6 transistors. So using this 6 transistors, this memory cell of SRAM is designed. This SRAM consume more power. Okay, this SRAM consume more power, and here we have a complex circuitry. That's why its storage capability is low. Okay, so it has a less storage capability and has a more power consumption. So okay, next we have a dynamic RAM, that is DRAM. Okay, here we have a dynamic RAM, that is DRAM. This DRAM is basically used, or says this DRAM is fabricated using MOS technologies with less power consumptions and with high storage capability. Okay, this DRAM is constructed using MOS technology and have a less power consumption and high capacity. Okay, so it has a this high power savings and high storage capabilities and a moderate cost. This DRAM use a single resistor and capacitor to store our informations. Okay, this DRAM use a single transistor and capacitor to store our information. So in a DRAM, our data or our informations are stored in a capacitor in terms of charge. Okay, here our data are stored in a capacitor in terms of charge. So here due to this capacitors, our data may lost over a period of time. Okay, our data may lost over a period of time. So there is a need of refreshing of a capacitor at a particular instant of time. Okay, so there is a need of refreshing in DRAM as our data are stored in a capacitor in form of charge, because this charge is basically leak or this charge is basically lost. Okay, so here our data are stored in terms of charge. So here due to this capacitor, our data may lost. So here there is a need of refreshing in a DRAM to hold our data. Okay, so this is our DRAM. So in this session we discussed about ROM and RAM. Okay, this ROM is a read-only memory in which we can retrieve our data. Okay, and this data of ROM cannot be altered, and we have a RAM that means random access memory, that is read and write memory. So stored data can be retrieved, or we can store the data, or we can write the data into the memory. So this is our semiconductor memories. Thank you.